Well, this is still chapter 9, and we started chapter 9, talk about climatic types on land, and we started deserts, and we talk about the classification, and we started with the desert. So, we're going to talk about more desert, and we will start with monsoon, and next video we will talk detail in monsoon. So, in different regions, of course. Annual precipitation thresholds for desert climates depend on the seasonality of the precipitation. Winter precipitation is subject to much less evaporation than that falling in the summer. Relative humidity also displays strong seasonality. In Riyadh, Saudi Arabia, values in the warmest month around 35 degrees Celsius range from 30% at 140 hours to 45% at 0700 hours, like 7 o'clock. In the coolest months, 14 degrees Celsius. Wow, that is really warm. However, corresponding values range from 45% to 70%. Conditions in the lower atmosphere over the deserts vary greatly with location and season, as illustrated in this figure for Hotan and Tamanrasset. The deserts in interior basins experience strong temperature inversion conditions in winter, producing especially low temperatures. Temperatures in the Taklamakan deserts in the Tarim Basin fall as low as minus 20 degrees Celsius. For example, conversely, in the Sahara in summer, there will be highly unstable air in the boundary layer due to surface heating. The instability can generate dry convection, giving rise to dust devils. These form when a plume of hot surface air rises rapidly through cooler air above. They develop when the vertical temperature's gradient at the surface exceeds 10 degrees Celsius, 100 meters, a adiabatic lapse rate. If conditions are just right, the air may begin to rotate. The column of hot air is stretched vertically, causing intensification of the spinning effect by the conservation of angular momentum. At the surface, hot air flows inward, intensify the vortex. They typically rise a plume of dust, as this picture shows, that a dust devil is a strong, well-formed, and relatively long-lived whirlwind ranging from small half a meter wide and a few meters tall to large more than 10 meters wide and more than 1,000 meters tall. It's very interesting. I never saw it, but this picture is a dust devil in Arizona. The primary vertical motion is upward, and dust devils are usually harmless, but can on rare occasions grow large enough to pose a threat to both people and property. With occasional strong winds and thunderstorm gust fronts passing over desert areas, the fine sand and dust may be lifted into the atmosphere, generating a dust storm. In North Africa, these are termed haboobs. They can be up to 100 kilometers wide and 1 to 2 kilometers deep, traveling at 35 to 50 kilometers per hour. Hence, deserts are sources of dust aerosols. And Saharan dust is transported over the North Atlantic and sometimes across the Mediterranean into Europe, where it can be observed in red rains. Dust storms from the Gobi Desert burrows across northern China and into the North Pacific. In southern Arizona, there were 7 to 9 dust storms annually, with visible reduced to below a kilometer in half of them. The major deserts exert an important influence on the climate of the adjacent areas between December and mid-March. Mid-March, the northeasterly Hamilton blows from the Sahara over West Africa. It brings very dry, cool, and dust conditions in November and March. Hot, dry, continental tropical air from the Sahara may be drawn northward into southern Europe. The cyclical by depressions moving eastward over the Mediterranean Sea. Wind speeds may exceed 25 meters per second. Temperatures are high and the air is dry over coastal North Africa, but cool, damp air behind the depressions affect southern Europe. In South Australia, a hot northerly wind from the deserts often preceded the eastward passage of a frontal system in summer. It brings hot, dusty conditions to the south of the country and is analogous to the cyclone of North Africa. Desert margins in many parts of the world are showing signs of desertification. Desertification means desert expansion due to land degradation as a result of both climate change and human activities. It is estimated that a total global area of 6 to 12 million kilometers square kilometers is affected by desertification. Degradation of vegetation cover, especially savanna grassland, as a result of overgrazing has been identified as a major factor. However, the issue is complex. In the Sahara of West Africa has prolonged decreases in rainfall since the 1970s has been a driving factor. The solution is to reduce livestock numbers, but this may be difficult with rising populations. Monsoons. The major monsoon regions of the tropics extend from Australia, Indonesia in the east through Southeast Asia and the Indian subcontinent and across Africa to West Africa. There is a separate region in northwestern Mexico and the southeast United States and another in central South America. The term monsoon is derived from the Arabic word wasim, meaning season. It refers to the major seasonal wind revealed over southern Asia from northeasterly in winter to southeasterly in summer in response to the different patterns of land and sea heating and temperature contrast. Basically, air flows from the cooler ocean to the heated land in summer and in the opposite direction in winter. However, this is very simplistic view. There is a heat low over northern India in spring with air flowing toward it, but this is well before the onset of the southwest monsoon and its heavy rains. To understand the South Asia monsoon, we need to examine the upper air circulation over the region. In winter, the upper level westerlies are split by the Tibetan Plateau, and you can see that, and the subtropical jet stream flows eastward south of the Himalayas, while the polar front jet stream is well to the north over Siberia. Air subsides beneath the exit of the subtropical jet stream due to high level convergence as the air slows down, and this sinking air gives rise to the low level northeasterly winds that flow out of India over the Indian Ocean. In May, the subtropical jet stream begins to shift northward, and in June, the heating of the Tibetan Plateau, which covers 4 to 500 meters elevation or 600 millibar, creates a shallow heat low and an upper level anticyclone. The anticyclone gives rise to upper level easterly winds over India and forms the tropical easterly jet stream at around 150 millibar, 13.5 kilometers, at about 15 degrees north. At low levels, warm, moist southwesterlies flow over the Indian Ocean, pushes northeastwards toward India. However, the monsoon onset begins over Burma and Assam because the rain-bearing systems are monsoon depressions that travel to the west and northwest, steered by the high-level easterlies. So some 46 of these depressions from over the Bay of Bengal and affect India each monsoon season. The southwesterlies bring rain to the western Ghats along the west coast of India, and it is the monsoon depressions and occasional tropical cyclones from the Bay of Bengal that spread rainfall to the north and the west, so that by July they reach southern Pakistan and the western Himalaya. Some moisture penetrates into southern Tibet, but the rainfall tends to occur in convective showers at night. Bangalore in south-central India receives about 100 millimeter per month during May to August, but then 300 millimeter in September as the monsoon retreats because the Bay of Bengal depressions are then moving across India at lower latitudes. The monsoon has irregular active and break intervals over India. The active phase of convection occur when the monsoon trough is a northerly location and breaks when it moves to the south. The active period typically occur at 15 to 20 day intervals and last about 10 to 15 days. The frequency of active periods during the summer season determines how much precipitation falls during the monsoon. There is large interannual variability in monsoon rains in both the timing and the amount. For all India, the monsoon provides 78% of the total average rainfall. The mean amount from 1871 to 1990 was 852 millimeter, with a range from 70 to 120% above the mean according to Parastania et al. Totals were low from 1901 to 1930 and 1961 to 1990, and high from 1981 to 1900 and 1931 to 1980.